maybe I think we should highlight this a little bit more. Chat models versus reasoning models. What are your thoughts on that? Like how would you describe to somebody the chat versus reasoning models?
The way that I like to describe these, I wouldn't probably use, I think I know what you're distinguishing there. I probably wouldn't call what you're calling a chat model there a chat model, because both typically, whether it's a reasoning model like O3 from OpenAI, or whether it's a
quote and chat.
Yeah, a quote unquote chat model like 4.0 or 4.1, 4.5 from OpenAI. So with what you're calling a chat model there, I describe those often as kind of like a stream of consciousness. Where, so the way that this takes a little bit of time to get into, but I can take a minute or two here to explain it. And I've certainly done this. If people regularly listen to the show, then they've heard this before. But the way that I describe it is it's like the thinking fast and slow that Daniel Kahneman and Amos Tversky and other researchers came up with over decades, I think mostly kind of starting in the 60s and 70s, digging into these two different thinking systems that humans have. So you have thinking fast and slow. The fast thinking system is what, up until recently, all of these generative models were just spitting out tokens, spitting out words or parts of words as quickly as possible based on whatever you just typed in. There's no reflection. You're just like I'm speaking right now. You kind of ask me a question, and I just hope that my stream of consciousness, the tokens that I'm spitting out of my mouth, are appropriate and relatively on the mark. So that's what all generative models were doing up until about a year ago. We started having our first reasoning models. So O1 was the first big reasoning model that was released to the public. And with these reasoning models, that's slow thinking. And so this is more like when you are thinking about some challenging business problem and you get out a notepad and a pen and you're jotting down, okay, what are the key things that I'm trying to solve in this problem? Who are the personnel or the resources that I have? And you start to map all these things together. Or it could be a math problem or a computer science problem where you're sketching out on a whiteboard how you might solve this computer science problem, this data science problem. So in any of those kinds of situations, it isn't linear tokens that are being output. You're iterating in your mind or on a whiteboard or on a piece of paper over like steps, and you're double checking to make sure that you had your assumptions correct. And this ends up being a really powerful thing for an AI model to be able to do, because it can dramatically reduce error rates, for example, by checking over your work and making sure that each of the steps is correct. And then you end up with, it's more computationally expensive. That's kind of the main trade-off. But you can end up, even without necessarily investing in a more expensive model in terms of model weights, just by iteratively processing, reflecting on work before outputting a result, you can end up with wildly more accurate, more nuanced, more complex solutions to problems. So yeah, we're seeing amazing results in the International Math Olympiad recently, for example, with models from both OpenAI and Google getting gold in this International Math Olympiad by using these kinds of reasoning models. And so we're getting really powerful results. Anyway, I probably gave a way longer answer.
No, that was spot on. Very, very useful. So it's one of the things for DIY bootcampers week one is explore the differences between the two and understand the use cases.